For our next lesson with rational expressions, we're going to take a look at what we need to do to simplify a rational expression when we're multiplying two separate rational expressions together. Now, this is basically the same as multiplying any set of fractions together. You're simply going to multiply the numerators, you're going to multiply the denominators, and then you're going to simplify from there. So, I mean, if we were to take a simpler look at this, you could multiply, let's say, 2 over 4 times 2 over 6. You could get 4 over 24. And then from there, you would need to reduce that down to 1/6. So this is the same process. We multiplied the numerators, we multiplied the denominators, we simplified from there. This time, however, we're going to be dealing with rational expressions instead of basic numerical numbers. So you can see here that our exponent properties are going to come into play. So if we multiply the numerators, and we're going to get 30x to the 5th, y to the 3rd, and then we multiply the denominators, we're going to get 20x, y to the 4th. Then we've got a situation where we want to basically break that up. So we want to deal with 30 over 20, and we want to deal with x to the 5th over x, and we want to deal with y to the 3rd over y to the 4th. And we want to deal with all of these separately and use our exponent properties to simplify them individually, and then of course bring them all back together for a final simplified rational expression. So you can see that remembering exponent properties is going to be an extremely important part of simplifying these expressions when we have to multiply them together. Now, let's take a look at an example of that. Simple problem 2. Go ahead and multiply these two parts together, and we'll take a look at that in a second. Okay, so if we were to multiply the numerators together, we would get 6 times 10, which would be 60. We're going to get x squared times x to the 3rd, which, remember, we add the exponents if they have the same base. And y to the 3rd times y to the 4th is going to give us y to the 7th. Now we're going to multiply the denominators. So 2 times 18 is going to give us 36. X squared times no other x value on the other side is just going to simply leave us x squared. And then y squared times y squared is going to leave us y to the 4th. Now we have to go through the process of individually simplifying these. So I'm just going to go ahead and break them up. And remember, those are technically being multiplied together. Just because there's no multiplication sign between them, you're basically multiplying these. And so I can write it as 3 different expressions being multiplied to each other. And so now I'm going to simplify each one of these individually. So I'm going to have 5 over 3. Since I had x to the 5th over x squared, that's going to give me 5 minus 2, which is going to give me x to the 3rd on the top. And you can see that there's 3 more x's on top than there are on bottom. And then the same thing happens with the y's. There's 3 more y's on top than there are on bottom. So that's y to the 3rd on top. And so now we've simplified each of the expressions. And so if you want to rewrite this so that it looks a little bit more like a normal fraction, you can move that. And that is your simplified rational expression. And so exponent properties come in very handy here. Let's go ahead and take a look at the next sample problem. Now, in the next sample problem, what we're dealing with is we are dealing with higher degree polynomials that we can factor. Now, here's the thing. The order of this is to multiply the numerators and then multiply the denominators and then simplify. But what I'm going to tell you is to factor everything first. Factor everything first. Factor all 4 individual parts if you can. That is going to make your life so much easier. And then keep in mind, if you're multiplying these two together, that's basically the same thing as writing them all together on top and on bottom. So there's no need to combine these together and make some real difficult polynomial to factor once you multiply them together. Just factor everything first, and then we can break it down from there. So for sample problem number 3, go ahead and try to work all 4 parts, and then then cancel out the common factors, and then reduce as much as possible. Okay, so go ahead and try that problem now. Okay, now this problem starts off fairly simple at first, but then takes a little bit of a curve at the end. So if you didn't get this all the way down to the final answer, don't stress out about it. It's an experience thing, and you're going to need to work enough problems to get experience doing these things. But let's just take a look at the first step. The first step is what I'm really most concerned about for you. Let's take a look at the 4x minus 4x squared. In this situation, what we have here is I'm going to factor out a common 4x. And that's going to leave me 1 minus x. On the bottom, x squared plus 2x minus 3, that's going to factor out to be x plus 3 and x minus 1. And then we're going to multiply by the other side, and we're going to factor that as well. So the numerator factors out to be x plus 3 and x minus 2, and then the bottom is just a 4 and an x. Now, what I'm going to do here is, technically, when we multiply these two rational expressions together, it's really the same thing. I'm just going to bridge the gap. It's really the same thing as writing them all over the same value there, the same fraction bar. And so anything over here can cancel out anything over here and vice versa. So let's take a look at that. We have a complete 4x and a complete 4x that can cancel out. We have an x plus 3 and an x plus 3 that can cancel out. And that's going to leave us with a 1 minus x, an x minus 2 on top, and then an x minus 1 on bottom. Now, if we take a look at this, we need to be sure that we don't make this mistake. 1 minus x is not the same thing as x minus 1. So we can't cancel out these factors here. Just to show you that, I'm going to rewrite the top one so that you can see what I'm talking about. This is basically negative x plus 1 times x minus 2 all over x minus 1. Now, at this point it would seem like we could stop, but in reality there is a little bit more work that we can do. There is a common factor that we could take away from negative x plus 1 to make it x minus 1. And if you look at it, you can pull out a negative 1. So we're going to factor out negative 1, which is going to leave us x minus 1. And then that's x minus 2. And then, of course, I have the x minus 1 factor on bottom. And if I look at that, I can now cancel out the x minus 1s. That's going to leave me negative 1 times x minus 2. And then if I distribute the negative 1, that's going to give me negative x plus 2, which is the simplified form of this particular problem. Now, that is your standard Algebra 2 rational expression problem. There's a lot going on there. There's a lot of movement, and so you're just going to have to be very aware of what you have left to do on any given problem. Okay, let's go to sample problem number 4 now, and we have a little bit of a different look here. We have a rational expression times just your basic polynomial expression. It's not written in a fractional form. So we need to learn how to deal with this. So go ahead and pause the video right now and see if you can maybe figure out what the method is of working this problem. Okay, hopefully, excuse me, hopefully you figured out that, first of all, if you want to write two fractions, that's basically saying the same thing as being over 1. So now what you really have is this. You have x plus 3 times 4x squared plus 2x plus 1 all over 8x to the third minus 1. Now, here's what I recommend you do. If you tried to factor 4x squared plus 2x plus 1, you may have realized that it just wouldn't factor. And what you basically have there, 4x squared is a perfect square, 1's a perfect square, but the middle term is not 2 times a times b, which means that that is not a perfect square trinomial. If you look at this expression a little bit closer, 8x to the third minus 1, hopefully you recognize that that is a difference of cubes, and since you've learned how to factor difference of cubes, go ahead and do that process. So I'm going to go ahead and just rewrite the top terms, and then I'm going to factor out the difference of cubes. And so here's how it looks. We get 2x minus 1, and since I took out 2x, that means I have 2 of them left over, which is the same thing as 4x squared. I took out one of the 1's, which means I have 2 of them left over, and then of course I'm going to multiply 2x times 1, which is going to give me my middle term, and I get my signs right. And if you look at that, we end up having 4x squared plus 2x plus 1, the same trinomial both on top and bottom, so they're common factors that you can cancel out. So our final simplified response would be the remaining factors. And that is a handful of examples and lots of factoring and exponent properties for you to remember anytime you're simplifying rational expressions that are being multiplied together.